Transmission medium overview. A transmission medium is a physical path through which data travels from a sender to a receiver in a communication system. It acts as a bridge for transmitting signals, whether electrical, optical, or electromagnetic. Types of transmission media. Transmission media can be broadly categorized into two types: guided media, wired media. Guided media use physical cables or wires to guide signals along a specific path. Common types include twisted pair cable structure composed of two insulated copper wires twisted together to reduce electromagnetic interference (EMI). Types: unshielded twisted pair (UTP), cost effective but less resistant to interference. Shield twisted pair (STP), includes a shield layer to protect against interference. Applications: telephone lines, LANs. Characteristics: low cost and easy installation, suitable for short distance communication. Limited bandwidth and susceptibility to interference. Coaxial cable structure consists of a central conductor, insulating layer, metallic shield, and outer insulation. Applications: cable TV, broadband internet. Characteristics: higher bandwidth than twisted pair cables, less susceptible to EMI, more expensive and bulkier than twisted pair cables. Fiber optic cable structure uses glass or plastic fibers to transmit data as light pulses. Types: single mode fiber for long distance communication, multi mode fiber for short distance communication. Application: high speed internet, telecommunications, data centers. Characteristics: extremely high bandwidth and speed, immune to electromagnetic interference, expensive and requires skill installation. Unguided wireless media. Unguided wireless media uses electromagnetic waves to transmit data without a physical path. Common types include radio wave, frequency range 3 kHz to 1 GHz. Applications: FM radio, television, mobile communication. Characteristics: travel long distance and penetrate walls, susceptible to interference and security issues. Microwaves, frequency range 1 GHz to 300 GHz. Application: satellite communication, point to point links. Characteristics: high data transfer rates and focused beams, requires line of sight communication. Infrared IR, frequency range below the visible spectrum 300 GHz to 400 THz. Application: remote controls, short range communication. Characteristics: cannot penetrate walls, ensuring security, limited range and sensitive to obstacles. Satellite communication relies on satellite to transmit signals over vast distances. Applications: GPS, international broadcasting. Characteristics: enable global communication, expensive and has signal delay. Wi-Fi and Bluetooth, use radio waves for short to medium range wireless communication. Application: local network and device pairing. Characteristics: easy setup and mobility, limited range and bandwidth. Characteristics of transmission media: bandwidth refers to the capacity of the medium to carry data. Fiber optic cables have the highest bandwidth. Authentication: the reduction in signal strength over distance. Coaxial and fiber optic cables experience less authentication than twisted pair cables. Interference: extreme signals can distort communication. Fiber optics are immune, while twisted pairs and radio waves are more prone. Latency: time taken for data to travel from sender to receiver. Physical cables generally have lower latency than wireless media. Cost: twisted pair cables are cheapest. Fiber optic and satellites are more expensive. Security: guided media like fiber optics are more secure and they are difficult to tap. Wireless media are vulnerable to interception. Distance: fiber optics support long distance communication with minimal signal degradation. Twisted pair cables and Wi-Fi are limited to short distance. Installation and maintenance: twisted pair and coaxial cables are easier to install. Fiber optics require specialized skills and tools.